Continuous distributions. Well, let's go back and ask the question, what is a discrete distribution? Huh? That's a discrete random variable. But what is a discrete distribution?
It's so easy. You guys are overthinking.
Huh? Not continuous. A discrete distribution is simply the distribution of a discrete random variable. So a continuous distribution is simply distribution of a continuous RV. Stands for random variable, not recreational vehicle. So it has a continuous support. In other words, it is some interval. When it comes to discrete random variables, we called it as probability mass function. Yes. So probability x is equal to some value k in the support of the random variable is the probability mass function. But when it comes to probability of x is equal to some value k in the support of a continuous random variable, what do you think that value is? Go ahead, Dennis.
The density function, probability density.
I'm not asking for the value of the density, I'm asking for the probability. Zero. I'm glad you brought that up. There is a difference between a probability and a probability density, and not the same. Why? Probability has a limit between 0 and 1. A probability density is between 0 and positive infinity. Good. So here we have a probability density function instead. I can't stress this enough. Probability density function doesn't give you probabilities, rather it gives you density values, and the domain, excuse me, the range of is from 0 to infinity. I can't stress this enough. I've had in the past students would take the entire semester, I put a question, true or false, f of x equals -2 on the interval 1, 2, the answer would be true. Why is the answer false? 0? Huh?
It's outside of the range.
It's outside of the range. The density cannot be negative, period. So it can be 0 all the way up to positive infinity. Easier way to remember this. There are two ways to remember this. One, think of a bell curve, right? Is there an inverted bell curve? Upside down? No. Always, anytime we talked about normal skewed, left skewed, it's always about the axis. That should tell you that it's always positive. Another way to think about it is to look at a probability mass function. Every single value in a probability mass function is positive, right? Because they are probabilities. Here, they are densities, but the logic is pretty much the same. Instead of having discrete values, say for instance, drawing 4 lines, I'm going to draw infinitely many lines about the x-axis. Do you agree? So it has to be above 0. Could be equal to 0 also, but it cannot be negative. Good. Density and probability, not the same. One case, no, it's still not the same. Cumulative distribution function, we denote it as f of x. It is the same here. But what do you think? The notation is the same, but what do you think the differences are? Oh. Well, we'll get to that part later. But in terms of the graph, for a discrete random variable, f of x is, what does it look like? You can look at your notes. Step function, right? It's a step function and we want it to be right continuous. So over here, what do you think that is? It's continuous. In terms of the step, what did we say? It has to be increasing, right? It doesn't have to be monotonically increasing because the CDF can stay flat. It is a non-decreasing function. A typical CDF is also a non-decreasing function, and we want to write the properties for a continuous random variable. It is non-decreasing and differentiable, yes.
So could you say that like the continuous CDF is sort of like the limit as the size of the step goes to 0?
Yes. What else do we have? Limit x approaches negative infinity. F of x is 0. Limit x approaches positive infinity. F of x is 1. F of x is integral negative infinity all the way up to x. F of t dt. Wow. F of t is a PDF. If that is the case, then what should f of x be? Calculus 1. Very good. So, Joe of my student is making me proud. So if we take the derivative of the CDF, we will get the PDF. If we integrate the PDF, we will get the CDF, but it has to be on the support of the density, which is why I'm starting at negative infinity. If the support starts at A, then it will simply be A to X. Does that make sense? Yes? Uniform distribution sort of is a trivial distribution. We can say X is uniform A to B or A comma B. In other words, A and B are the endpoints of a uniform. They would be the parameters of the uniform. Zero, please. Yes. Now, with discrete distributions, if you sum all the probabilities, what would that equal to, or what should that equal to? One. So how would I extend the same logic to a continuous distribution?
Like a Riemann sum.
A Riemann sum, very good. But what is, I mean, a Riemann sum is an approximation, but
Well, you mean integral.
integral, right?
I assumed you understood that I applied an infinite Riemann sum, but you know, it's not.
Wow, pardon my ignorance. So limited branches infinity, Riemann sum, we're pretty much finding the area under the curve. That is a horizontal line. So that said, what should that value be? I want to know what that value is. The average. What do you mean by the average? So that has to be 1 over b minus a. One of the ways we try to do this would be to integrate this density and make sure that the area under that curve would become 1. Now, Benton, how did you come up with 1 over b minus a?
Well, b minus a is the width of the rectangle, then 1 over b minus a should be the height of the rectangle, such that the reciprocal times itself should equal 1.
Yes, that looks like a rectangle, correct? I did a good job, actually. And if you multiply the 2, what is the area? 1. So that has to be 1 over b minus a. So x is uniform a comma b is simply a uniform random variable defined on the interval a to b. And f of x is 1 over b minus a, for x is between a to b. You can put equal to, doesn't matter, because we're not looking at an exact probability. 0 otherwise. Good. we know by definition less than or equal to x less than or equal to x is the CDF. And I related the CDF to the PDF, which would be integral negative infinity all the way up to x f of t dt. Yes. So the support of our density function is from a to b. So for any given x that is between a and b, including the endpoints, this would be a to x. F of t, which simply is 1 over b minus a, multiplied by dt.
From 0 to A.
1 over b minus a is a constant. What is the integral of dt? T. So f of x would simply be equal to 1 over b minus a times upper limit minus lower limit x minus a. But we can't just leave it there because it's not properly defined. So the way we properly define this is f of x is equal to 0 for x less than a. X minus a divided by b minus a for x in a comma b. One for x greater than b. Now at the end point that these pieces would just be equal to each other because the function is continuous. Anyone could, come up with the formula and say, oh, this is what it is. I integrate density negative infinity to x. I get the CDF. But why though? Why the integral? Benton had the answer ready. Now, if I asked you, find the probability x less than or equal to x for a discrete, this is sided. Let's say one, two, three, right? And I asked you, what is the probability of x less than or equal to 3? Do we agree that that is discrete? Yes. And if I wanted to find the probability of x less than or equal to 3, how would you find it? You add them all up. So in this case, x is less than or equal to x. So I want to add everything here up, right? For a moment, I could just treat that as a density or probability, but the logic is same. So I have infinitely many lines, vertical lines such as these. I want to add them all up. What is that equivalent to? Adding infinitely many lines between a and x. Huh? It is equivalent to integrating, right? Can't say I'm not going to draw infinitely many lines here, but I will try to draw as many as possible so that you get the idea, right? Yes. If I drew infinitely many of them, just shading everything, you get the area, right? Now, I could have gotten that formula by looking at that rectangle. Yes, that rectangle. The height is still the same, 1 over b minus a. What is the length? X minus a. Length times width, I have x minus a divided by b minus a. Does that make sense? So when we try to find a cumulative probability, x less than or equal to x, all we are finding is the area under the curve. Good. The expectation with respect to a discrete random variable, x, let's say the support is, I'll just write it in support of x, where x is the discrete random variable. How do we find the expectation? What is the formula? So, all I can write is k times the probability of x is equal to k. Right? That is the definition of expectation. Take a guess. What would it be when it comes to a continuous random variable? The sum would become an integral over the support of x. I'll just call it x and omega, and x times f of x dx. To find the variance, we need expectation of x squared. Expectation of x squared, how did we find that? Going to put omega there to indicate that it is the sample space. How did we find expectation of x squared?
Is it the same as k squared?
It's the same, but we replaced it by k squared. So here, the support of x, what would the integral be? Two x squared times easy way to remember. Sum becomes an integral because it is continuous. Discrete values of k become continuous values of x over the support of the random variable. Probability mass function becomes the probability density function. Does that make sense? You don't even have to memorize. No one will know the other. Are we clear? Okay, so there are several continuous distributions. Of course, I'm not going to get into every single one of them. I'm going to talk about exponential. I will talk about uniform 0, 1. Right, I'm going to talk about gamma distribution. The book talks about beta at a later point in time. So I might do beta distribution also. All of those are important distributions. So exponential, gamma, beta, normal, uniform 0, 1.
Chi-squared.
Chi-squared is just the gamma distribution. So we'll just plug in the parameters k over 2, k over 2.
If the continuous distribution is based off of y, shouldn't the integral be like y times m y t1?
What?
If the continuous is y, next to very top, then continuous is y.
Thank you. I used y. He waits until the very end to correct me.
Sorry, I didn't want to sound rude.
Well, you did that earlier when you said, I don't know, read my own sum. Are we good?
Yes,
Yes.
be rude again.